am once again with you. Today my topic is hyperbola. What is hyperbola? A hyperbola, we write definition of hyperbola. A hyperbola is the set of all points in a plane the difference of whose distances from two fixed points is always constant. Definition of hyperbola is a hyperbola is the set of all points in a plane the difference of whose distances from two fixed points is always constant. Now what the definition says that if there are two fixed points, say F1 and F2, and P be a point in the plane, P be the point in the plane, the distance from F1, PF1, and distance from F2 is PF2. So, PF1 minus PF2 is constant. There are so many points. So, the shape of hyperbola will be as like that. Maybe other point also, suppose it is Q. So, the difference, that means QF1, QF2. Difference means here farther, subtract the larger distance, the point which is farther. As in case of PF1. So, F1 point is at more distance than F2. So, we will find PF1 minus PF2. And in this case, the Q is farther from F2. So, QF2 minus QF1. QF2 minus QF1. This distance is always constant. And these fixed points are called foci, plural of focus, as we have discussed in ellipse. Now there are some other definitions at center. The lines segment joining F1 and F2 is this. And the midpoint of F1 plus F1 and F2 is C. And this is called C. So, the midpoint, the midpoint of the line segment joining F1 and F2 is known as center of hyperbola. Okay. And transverse axis. Transverse axis. The line through these foci is called transverse axis. The line through foci is called transverse axis. The line through foci is called transverse axis. Is called transverse axis. Now, the line which is through the center and perpendicular to transverse axis. This line is called conjugate axis. So, what is definition of conjugate axis? Line through the conjugate axis. Line through the center and perpendicular to transverse axis is called conjugate axis. Now one more term is there, vertices. Vertices are these points where the hyperbola, the point at which hyperbola intersect transverse axis is called vertices. There are two vertices because hyperbola intersect transverse axis at 2 points, as in case of ellipse, 2 vertices. So these are the terms related to the hyperbola. Now we denote here the length of transverse axis, or you can say distance between two vertices is 2a. Distance between two vertices is 2a. Let A and B, or you can say any point A dash, A, B are the vertices of hyperbola, and the distance between two foci is 2c, and the quantity B is equal to c square minus a square, or you can say c square is equal to a square plus b square. Now, if you remember, this type of relationship we have studied in case of ellipse. The difference is, in ellipse, c square is equal to a square minus b square, and a and b are the length of semi-major axis and semi-minor. But here a is the 2a is the length of transverse axis and 2b be the length of conjugate axis. So don't be confused. You always remember the relationship for hyperbola and ellipse also. So relationship is c square is equal to a square minus b square. Now we are coming to the constant. As we have defined a constant in the definition. What constant? We have defined that the difference between the distances from two fixed points is always constant. To find constant. Now, we have to find which constant, what is the value of this constant. Now, as we have seen, the difference of the distances from two fixed points is always constant. So, what is difference? This is Pf1 minus Pf2, as I told in the definition. Now, P point lie on the hyperbola. Similarly, position of P may be here. We can say B also lies on hyperbola. A also lies on hyperbola. So, the distance of these points from two fixed points is always constant. So, find. We consider first B point. So, BF1, because BF1 is larger distance than BF2, is equal to A. In this case, F2 is farther distance. So, AF2 minus AF1. Now, what is BF1? BF1 distance. Here C we have taken origin. So, point B, as the length is 2a of transverse axis. So, B coordinate of B will be A0, and and coordinate of A will be minus A0, F1 as C minus C comma 0 left side and F2 as C comma 0. C we have taken at 0, 0. Now BF1. BF1 is the distance. We can say BA plus AF1. BA plus AF1 minus BF2. Similarly, what is AF2? AF2, you can say AB plus BF2 minus AF1. AF2. What is AF2? AF2. AF2 is AB plus BF2. AB plus BF2 and minus F2. So AB, BA distances we can implies that 2AF1 is equal to 2BF2. So 2, that means AF1 is equal to BF2. Okay. Now difference. Difference is here. BF1 minus BF2 is equal to AF2 minus AF1. BF1 is BA plus AF1 minus BF2, right? But we have just proved from this relationship that AF1 is equal to BF2. So BA plus BF2 minus BF2. So BA. The difference is BA. And what is BA? It is the distance between two vertices, and it is 2A. So the value of this constant is 2A. Similarly, you can find from this that because we have already taken it is what is AF2? AB plus BF2 minus AF1. As just we have proved, BF2 as AF1, put AF1 minus AF1. So constant is AB, or you can say this constant is 2A. That means difference of two fixed point is always equal to 2A. Next, we are coming to one more definition is there, eccentricity. Eccentricity of an ellipse is given by C upon A. What is C? C is the distance from center to one of the foci, and A is the distance from center to the one vertices. And as you C is always, that means C is greater than or equal to A. So E, that means eccentricity never less than 1. It is always greater than 1. Eccentricity of an ellipse. Now we will find a standard equation. A standard equation of hyperbola. A standard equation of hyperbola. If orientation of hyperbola is like that transverse axis lies along x-axis. If transverse axis lies along x-axis and conjugate axis lie along y-axis and center at 0, 0 origin, in that case, and A dash transverse axis and length of transverse axis as we have taken 2A, and always remember transverse axis along x-axis and conjugate axis along foci F1, F2. Coordinates of foci as minus C, 0 and C, 0. Two vertices A as A, 0. A, it is left side of origin, so minus A, and A dash A, 0. The standard equation of such orientation of hyperbola is x square upon a square minus y square upon b square is equal to 1. So what are the terms? One is center at 0, 0. Vertices, these are vertices minus a0 plus a0, and foci as shown in figure, foci as plus minus C, 0. Length of transverse axis is 2A and length of conjugate axis 2B. Eccentricity you can find with the relationship that C square is equal to A square plus B square. If you find C, then eccentricity we can find easily. Now, second type of hyperbola, second form, not type, of hyperbola. When transverse axis lie along y-axis. Transverse axis lie along y-axis. Center as it is 0. So foci will be lie on transverse axis. F2, F1. Foci will be 0, C because it is lie on y-axis, 0, minus C. And vertices as A dash. A is minus A, 0 and A, 0. And y-axis is transverse axis. And x-axis in this case is conjugate axis. length of transverse axis and length of conjugate axis remains same as 2a and 2b. Equation of hyperbola, standard equation for such type of orientation is y square upon a square minus x square upon b square is equal to 1. So how can we find from equation? How can we identify? See, x square upon a square. It is a positive term. If denominator of positive term shows that transverse axis lies along x-axis or y-axis. Positive term is here x square upon a square. So, 2a is the length of transverse axis. So, transverse axis lies along x-axis. Here, the positive term is y square upon a square. Its denominator a square and 2a is the length of transverse axis. So, its transverse axis lies along y-axis. So, that was about the standard equation of hyperbola. Now, one case may arise if a is equal to b. What happened? If we put in this standard equation, x square upon a square, y square upon b square is equal to, or at the place of b we replace a 1. So equation will be converted in x square minus y square is equal to a square. This is called equilateral hyperbola. Equilateral hyperbola. It means a hyperbola in which a is equal to b is called equilateral hyperbola. Now, one more observation you can see. Standard equation of hyperbola has x has even power and y has x square term and y square term you can say. So hyperbola is symmetrical about both the axes. Either in case, hyperbola is symmetrical about both the axes. You should remember that hyperbola is symmetrical about both the axes. And that's about the hyperbola. In our next video, we will solve some problems on hyperbola. Thank you so much.